Now I give it over to Mark from Euresys.
Thank you very much. Thank you very much for the introduction. Thank you very much, everyone, for attending this presentation. I'm Mark, the CEO of Euresys, and the topic of the presentation today is a CoaXPress-over-Fiber. That's a very nice example of standards in action. A word about our company, Euresys. We are a manufacturer of machine vision components. This includes a set of frame grabbers that are compatible with CoaXPress, camera links, and even older analog cameras. We also design FPGA IP cores, implementing the GigiVision, CoaXPress, USB 3 Vision, and different imaging sensor interfaces. And then we design machine vision software libraries that are meant for image analysis and inspection. So you see that we have to face and use with a lot of standards and machine vision standards in particular. Today, I'm going to talk about CoaXPress and, generally speaking, what are the benefits of the CoaXPress standard for high-speed vision application. As far as we are concerned at Euresys and for our markets and for our kind of application, CoaXPress has been a very, very successful standard. For us, it is the best standard for high-speed machine vision application. It is not the #1 standard in the market, but for our applications, and at Euresys, we are very active in machine vision business. We mostly sell our products to machine makers, OEM machine makers that design high-end inspection systems for the electronics and semiconductor markets. In this market, CoaXPress is really seen as the #1 standard. It dates back to 2008, but today there are more than 50 companies, and many of them are present on this show. There are more than 50 companies worldwide providing cameras, cables, frame grabbers, and different kinds of accessories compatible with the CoaXPress standard. Basically, CoaXPress allows you to acquire images from the fastest and highest resolution cameras available. The CoaXPress standards defines communication over a single coaxial cable, currently with the CXP12 speed at 12.5 gigabit per second raw data transfer rate, which leads to 10 gigabit per second net data transfer rate. Over that single cable, we can transfer high-speed data from the camera to the host. That can be a frame grabber on any kind of receiving device. We can also send asynchronous commands to the camera. And that feature is super important because we need a no jitter, low latency system to trigger the camera and send other kinds of signal to the camera. CoaXPress also includes power with a system called power supply to the camera, POCXP, and we can provide sufficient power for industrial cameras that do not require a specific connection for the power supply. At Euresys, we provide a complete range of frame grabbers and IP cores that are meant to build systems and cameras based on the CoaXPress standards. For what reason do our customers use CoaXPress? I have asked this question to many of our customers, and the #1 answer has been, we want high bandwidth from the camera to the frame grabber. We use a CoaXPress to acquire images from the fastest and highest resolution cameras. There are also other advantages of using CoaXPress. You have seen in the previous slide, we have a frame grabber with 8 CoaXPress connections. So this means that you can connect 8 CoaXPress cameras to a single frame grabber. There's no other standards that provide that kind of capability. With CoaXPress, we have a precise camera synchronization between different cameras connected to a given card or several cards in the PC, or even cameras connected to different PCs. Because we use a frame grabber, and frame grabber is really a good thing because we have a specific programming and capabilities inside the frame grabber to control the camera and maintain a very tight and consistent timing. Because we use frame grabber, we can acquire images even at the highest data rate without loading the CPU. This means that our customers make machines that have to process images in real time. They have access to the full CPU power for processing their images. And generally speaking, the coaxial cable, which is used by the CoaXPress interfaces, is really well accepted in the market. Among all these advantages, the first one is the most important. It is the bandwidth. This is the bandwidth that has driven the evolution from camera link to CoaXPress. And there is a real need for such bandwidth. A single CoaXPress link at 12.5 gigabit per second provides a net bandwidth of 10 gigabit per second. This is the same bandwidth as 10 gigi. So what is the difference between GigiVision and CoaXPress when we talk about bandwidth? The big advantage of CoaXPress here is that CoaXPress is scalable. Actually, today, we almost do not have any application that use a single CoaXPress link. Most of the applications we have use 4 links. And if you look at the cameras around at the show today, you will find a lot of cameras with 4 CXP6 links or 4 CXP12 links for a total net bandwidth of 40 gigabit per second. There are, and they will continue to evolve, there are a lot of CMOS sensors that need these 40 gigabit per second. So there is a real need for an interface at 40 gigabit per second. You even see an example of a camera there at the bottom of the photo that requires a 16 connection just because of the bandwidth requirement. So we made this conclusion at Euresys. Our most successful products, our most successful applications need 4 links. Now 4 links at 12 gigabit per second, CXP12. Where do we go from there? What is the next step? And we started to work on a new idea, which is CoaXPress-over-Fiber. When I say we, this is not just Euresys. These are all the companies that work together at the CoaXPress Technical Committee to define the next evolution, the next iteration of the CoaXPress standard. So here comes CoaXPress-over-Fiber. CoaXPress-over-Fiber is an addendum to the existing CoaXPress standard. It is a JIIA standard. What is the JIIA? It's the Japanese Industrial Imaging Association. This is the association which is the official host for the CoaXPress standard. CoaXPress-over-Fiber is a JIIA standard since February 2021, so for more than 1 year now. Technically, at the lowest level, CoaXPress-over-Fiber is a way to run the CoaXPress protocol as it is, unmodified, over a standard network connection, over a standard Ethernet network connection. And that's a very clever way to move the standard ahead. CoaXPress-over-Fiber uses standard electronics, chips, IP cores, connectors, and devices, cables, fiber optics that are designed for networking, that are designed for Ethernet. But the protocol remains CoaXPress because we are super happy with CoaXPress. We are very happy with the protocol. We are very happy with its capabilities. So the protocol remains CoaXPress. It's not Ethernet or it's not GigiVision. With CoaXPress-over-Fiber, we keep the advantages of CoaXPress, and we benefit from the evolution of networking equipment towards higher bandwidth. We benefit from the low cost, the low manufacturing cost of standard Ethernet and networking components, such as the connectors, the cables, the transceivers, and so on. And some camera manufacturers may even benefit from the common IP and common components between Ethernet, CoaXPress-over-Fiber, and GigiVision. A big advantage, of course, as the name implies, is that we start using fiber optics, which are really better than copper cables for high-speed applications. With fiber optics, we have access to much higher, virtually unlimited bandwidth. The bandwidth is only limited by the electronics around the fiber. There's no limit in the fiber optic itself. We have access to much longer reaches, much longer cable distance. We have now complete immunity to EMI, to electrical noise. And for those of you working on the factory floor, you know that electrical noise is maybe a problem in some machines, especially with standards such as a camera link. Fiber optic cables are also much less bulky and much lighter than any other kind of cable that we have in the industry. We can also reduce the total power consumption of the system because transmitting images and this interface require much less power. There's one drawback, though, by switching from copper to fiber. It's that there's no such thing as power over fiber. The amount of energy that is transmitted through the fiber is very, very little, and there's no way to transmit a significant amount of power through the fiber. So this is what we have done at Euresys. This is our first frame grabber compatible with the CoaXPress-over-Fiber standard. We have chosen to use a QSFP Plus cage, or what we call a QSFP Plus transceiver that you see at the bottom of the image here. QSFP Plus stands for Quad SFP Plus. So this is 4 times an SFP Plus connection. What is the meaning of SFP? It's a standard, a small form factor pluggable module. With QSFP Plus, we use a transceiver module which is plugged into the card. And the good news is that this kind of approach is really flexible because there are different kinds of transceivers available on the market. They are also widely available because these transceivers are used in networking applications, and they will be easily sourceable for this kind of application. So you see the example here. This is a QSFP Plus transceiver, which is plugged inside the cage. On this side here, we have the electrical connection, and on that side there, we have the fiber connection. The main goal of switching to fiber is to increase the bandwidth and provide an interface with more bandwidth for the future. So where do we stand in the terms of bandwidth with CoaXPress-over-Fiber? These are typical application bandwidth that we see with copper applications, so the standard coax over copper interface. So this is the scale in gigabit per second. So you can see that GigiVision is at 1 here. Then we have 5 gigi, 10 gigi here. With CXP6 and 4 cables, we are at a net bandwidth of 20 gigabit per second. And with a CXP12 and 4 connection, we are at a net bandwidth of 40 gigabit per second. This is where most of our applications, most of our CoaXPress applications are today either 20 or 40 gigabit per second. We have a few applications that use 2 cards and go up to 80 gigabit per second. By switching to fiber and QSFP Plus, we stay at 40 gigabit per second, but we move over fiber. However, the technology is there, and we are very active at Euresys developing products for that kind of speed. QSFP28 transceivers are available for networking application. QSFP the 56 transceivers are also available. You can walk the show and you will find these transceivers on some booth here. So we have access to 100, 200, and even in the future 400 gigabit per second by using the corresponding transceiver. So we have a clear evolution path from 40 to 100, 200, and 400 gigabit per second by adopting this networking technology. This is a photo that was actually taken on our booth 1 year ago here in Stuttgart. I had to submit this presentation 2 weeks ago, so I used the photo from last year. But you can drop by our booth, Euresys in the other hall, and you will see 4 or 5 different CoaXPress-over-Fiber cameras. You can see that the cable is really light, and we provide a communication at 40 gigabit per second here between the camera to the frame grabber in the PC here. This is another example of a camera that uses two QSFP Plus transceivers. To end the presentation, I will give you more information about the type of fiber and transceivers that we have used so far. We have used two of them. We have used optical connections with multimode fibers, MMF multimode fibers, and this type of fiber have a reach of 150 meters, which is more than enough for all our machine-related applications on the factory floor. This kind of transceiver, this kind of fiber is really, really low cost. We are talking much less expensive than camera link, much less expensive than CoaXPress here. So the cable is actually reducing the cost of the overall application. You can see the fiber connectors. We have 12 fibers here in the MTP MPO connector. If you need a longer reach, there are single mode transceivers and single mode fibers that can reach up to 40 kilometers. So these are the systems that you will use for remote vision applications, for example, that need a much longer distance between the camera and the frame grabber. These are also type of transceiver that we have used in applications such as sports imaging. If you want to transmit video over a long stadium, for example, that's the kind of solution that works very well. There are also, and all these are standard products, there are also split cables. So, this is the one we see here. QSFP Plus having 4 fibers and 4 connections, 4 lanes between the camera and the frame grabbers. It is possible to purchase sort of a spider cables that will allow you to connect 4 cameras to a single QSFP Plus transceiver. And last but not least, there are some active optical cables in which the fiber optics is directly connected to the transceiver. This is the kind of cable that would provide the highest level of robustness, and this is the kind of cable that we use, for example, in AOI machines, where the camera is moving, and there must be a firm connection between the camera, the transceiver, and the fiber optics. If you want more information about our products and the CoaXLink QSFP Plus in particular, or CoaXPress-over-Fiber, please drop by our booth in the hall number 10. And thank you very much for your time.
Thank you, Mark. Thank you. Hello, hello, hello. Yes. Thank you, Mark, for the presentation. We have some time for questions. Do you have some questions from the audience? Yes.
Thank you. We actually, in my company, use a lot of CoaXPress cameras. We're having a little bit of issues with the electromagnetic radiation. So I'd like to know if do you produce, or will you produce an adapter that would allow me to use my cameras, transform them to optical, and then maybe transform them back into classical CoaXPress?
Yes, we actually have what we call a converter, which is under design 9. The product has not been launched yet because we are facing some component shortage issues, but the design is done now. So we have designed a quad CXP12 converter into QSFP+. So you can convert the CXP12 signal into a QSFP+ CoaXPress-over-Fiber connection that goes directly to our CoaXLink QSFP+ frame grabber. And then it's a way to use fiber connections with a standard copper CoaXPress cameras.
Okay, thank you.
Thank you.